What if you could point your phone at a messy drawer full of tools and 30 seconds later have a print-ready Gridfinity tray, perfectly sized for every single one of them? No CAD, no measuring, just a photo. And that's just the tip of the iceberg, because over the last few months, a whole new wave of 3D printing tools has quietly cropped up, and most of the community hasn't even touched them yet. Tools that let you print with 16 million colors from just 4 filaments. Tools that add photorealistic textures to any model. Tools that can add a photograph to the surface of your 3D print. And even an idiot like me figured them out. So in this video, I'll show you which ones are actually worth your time. And stick around to the end, because I have a small announcement about something that I've been working on that I think you're really gonna like. Let's get after it. Let's start this video off with Gridfinity, because the tools here have completely changed since most of us started printing bins. Since Gridfinity's inception, it's become more and more common and popular to create these kinds of cutout Gridfinity boxes for your various tools, rather than large empty bins. So over the years, a lot of automated tools have cropped up to make it easier to generate these types of bins. From outline.georges.lv to shapescan.pt and many, many more. But the reigning champion, at least for this type of bin, has got to be Tooltrace.ai. While it's been covered before by some other top 3D printing channels, a lot has been added recently, so it is worth covering again. For those of you who don't yet know about it, Tooltrace allows you to basically snap a photo of your tools on a standard sized piece of paper and then transpose those shapes plus any additions like finger scoops, cutouts, or any other shape onto standard Gridfinity bin sizes. Now, to be completely honest, the first few times that I tried Tooltrace, I wasn't super impressed. But it seems like they've really been working hard to improve the tool, because when I went to test it out and compare it to the next service on our list, I had a really positive experience, which actually prompted me to bump it up to the top of this list. I particularly liked how effective the AI tool tracing was, how it automatically and dynamically chooses the best bin size for my tools, and how I could snap a bunch of tools all at once and then generate bins for them together or one by one. Plus, since I last used the tools, the interface has gotten really good. Best of all, you can do quite a lot with the free version here, and unlimited access to the pro features costs like $8 a month, which to me seems more than fair. Link in the description. With that said, there are a few things that Tooltrace is a little bit less suited for, and that's probably why another up-and-coming service has thrown its hat into the ring. It's called GridPilot, and the principle is more or less the same. You use AI image recognition to trace your tools. But with GridPilot, you seem to have a bit more granular control and flexibility. You can, for example, quickly add common circular tools like drill bits, sockets, taps, dies, or you could even change the individual pocket colors. If I'm honest though, the much newer GridPilot is still quite buggy, at least at this stage, and the workflow is a little bit clunkier than the highly automated Tooltrace. But I have been beta testing it for a little while now and providing copious amounts of feedback to the creator, and he's been incredibly responsive and eager to improve the software in any way he can. Plus, in the 3D printing community, we love having options. So if you too would like to try it out and provide feedback, I'm quite sure that they would appreciate it. You can generate up to 100 cubic inches worth of bins free per month, and after that, prices start at just £3, so why not give it a try? Speaking of options, while I was researching this video, I actually discovered one more service that can trace your tools onto Gridfinity bins like these, but this one is actually open source, which everybody liked that. And it can be run locally. It's called TraceFinity, and honestly, it works just like the other two tools that I've mentioned before. Now, I found it to have even more customization options, such as chamfering the edges of your cutouts, or customized smoothing, or even adding custom shapes. But I do think it's really cool that in addition to having generous free and paid plans, TraceFinity has published their code for free on GitHub, which allows you to self-host. Gosh, I love this community. But what if what you need isn't just a simple 2D cutout projection, but rather a 3-dimensional cutout to match the mating surface of your tool? Sure, you could download a solid bin and then import it into your slicer alongside a 3D model of your tool, and then perform a Boolean operation inside of the slicer, but that's a lot of steps. And plus, what if you actually need to create the 3D model of your selected tool first? For that, I recommend the Gridfinity FeatureScript upgrade for my personal CAD suite of choice, which is OnShape. Despite being a professional-grade CAD, OnShape is cloud-based, which has two benefits in this particular scenario. Number one, it means that you don't have to burn like 9+ gigabytes of storage space on your computer using Fusion just because you want to create some custom bins. But more importantly, number two, it means that there's a huge library of public designs that other people have already created within OnShape. So you can just search for them right within the CAD interface and insert them directly into your model with no CAD drawing. So anytime I need a more complex bin design, this is my personal workflow because it's just a few clicks and it is completely free. Side note though, OnShape does sponsor this channel, so if you are an engineer, I do have a link below in the description that will get you up to 6 months of their pro version for free. But what if you're looking to generate more traditional bins for things like hardware? Sure, you could search around the various model repositories and almost certainly find exactly what you're looking for. But realistically, with so many models on so many of the different websites these days, it's probably going to be much faster and easier to just generate the exact model bin you want, exactly how you want it. And for a few years now, my go-to generator has been the multifaceted website by PerplexingLabs. There, you can generate anything from classic or vase mode Gridfinity bins to base plates, the rugged carrying cases for Gridfinity, or even alternate ecosystems like the honeycomb storage wall. While the interface is starting to look a little bit dated, I think that you'll find that you can cover the vast majority of beginner and even intermediate use cases for Gridfinity with this one tool alone. You can even fiddle with the bin sizes to create half-size increments should you wish. Best of all, it's time-tested, reliable, and somehow completely free. But I do hope that you will join me in donating to help keep it running if you find it valuable, because up until I started researching what's out there for this video, I was pretty sure that this one tool was going to be the GOAT forever. That is, until I discovered GridfinityGenerator.com, a flashy and newer entrant to the space. Now at first glance, this website seems a bit basic. Limited options for base plates, a cutout function that doesn't quite work yet. But then you start digging into the main attraction, which is the box generator. And pretty quickly, you start to wonder if this is the future. Sure, you're more limited on the types of bins and base plates that you can generate, but both the level of customizability and the ease of use feel much more modern. Here, instead of a long list of drop-down menus that can get a little confusing and overwhelming, you simply add elements for your walls, your scoops, and your labels. What takes us to the next level, however, is the granular control that you have over those elements. You can divide bins unevenly. You can add scoops only on certain segments or in certain directions. And you can just generally trick out your bin in all sorts of non-uniform ways. Best of all, this isn't confusing or overwhelming like it used to be back when you had to code these types of bins by yourself using OpenSCAD. If you'd like to try it out, you can generate up to 3 models for free or sign up for a paid plan starting at just €6 a month. By the way, you might be wondering how in the heck I print out these types of custom multi-material bins. I mean, after all, PLA and PIBA are very much not compatible in terms of bonding to one another. But also 99% of consumer printers out there, including those from the leading brands, just can't do multi-material or multicolor prints when using a flexible filament. So if you do want to do this kind of thing, or, multicolor printing that doesn't take a century with all of the unloading and loading and filament swaps, then you are going to need a proper tool changer, like the U1 from this video's sponsor, Snapmaker. Not only is the U1 hands down one of the best 3D printers I've ever used, but it is also fully open source, and it's built by a company that respects and encourages both open source and our rights as consumers to modify, upgrade, and repair our machines. So while other brands are out there sending nasty legal threats to open source developers just trying to restore the factory functions that they've taken away, Snapmaker is actively hiring those developers and featuring them and supporting them. So if you want high quality 3D prints and a fantastic user experience without compromising on your privacy, your consumer rights, or the ideals that made 3D printing what it is today, we'll go ahead and leave a link in the description to pick up your very own U1, which by the way, is now in stock and shipping in most markets. All right, let's get back to the video. Up next, we're looking at a class of tools that allow you to customize and personalize your models into something new and unique. First up, an exciting new tool by my buddy Stefan over at CNC Kitchen. It's called BumpMesh, and in case you missed the video that he did all about it, it works like this. First, you upload a boring STL file with no character. Then you pick a texture and tweak the parameters of where and how that texture is applied. Finally, you download and print your new, unique, and customized model to impress your friends. Now, I've been playing around a little bit with BumpMesh, and it really is a very powerful tool that can level up your 3D prints. If you're the type of person who just hates seeing layer lines or the look of plain old plastic, I really think you're gonna find yourself coming back to it again and again. So well done, Stefan. The only downside that I can see is that swapping out smooth surfaces for much more detailed ones is going to dramatically increase your print times by a factor of 2, 3, or even more. But in many cases, I think it's probably worth it, especially if you, like me, have extra printers that are just sitting around anyways. If, on the other hand, you want to go even further on the personalization, then how about slapping your face on the side of a benchy, or a vase, or whatever you want, really. For that, you'll need to check out Prime 3D by fellow content creator 3D Revolution. Not only does Prime 3D give you a more powerful and versatile interface for painting your 3D models, but it adds some crazy, mind-bending new features as well. You could, for example, paint a gradient onto your model to be printed using WCYM filaments. Or you could add a literal photo to any of the surfaces. What's craziest to me, though, is how Prime 3D actually accomplishes this. Obviously, it's using dithering to mix and match the colors, but it's achieving it by drawing incredibly tiny lines on the actual model, which can then be imported into the slicer. It's honestly pretty mind-blowing, and it's definitely worth trying out to see how it works in action. Now that you've got your 3D model ready to go, you'll need to slice it and turn it into G-code that your printer can actually print. So let's talk a bit about some of the crazy innovations happening right now in the world of slicers. Up until recently, there's been a really bizarre and frustrating point of friction when it comes to 3D printing: mobile access. See, while you can start prints, monitor them, browse models, and even control most 3D printers remotely via mobile, up until very recently, you couldn't actually slice your own G-code on the go. You just have to hope that someone else out there had created G-code for the exact model or models that you wanted, with the exact settings and the exact filament, or wait until you were back at a computer. But all that changed about a year and a half ago with Prusa's EasyPrint, a web-based slicer that covers about 80% of your slicing needs wherever you are. Not only is EasyPrint a lighter and less intimidating slicing experience on your desktop, but it also works perfectly on mobile through the Prusa app. And don't worry, because good guy Prusa has of course opened it up to and added print profiles for all the different 3D printers out there, even those of their competitors, though some of those competitors have very stubbornly declined to allow printing directly from EasyPrint. Regardless, if you do have one of the many printers that connect to EasyPrint, I strongly recommend that you check this thing out. No, you can't do all those advanced granular settings that you might do at the computer, but for your everyday use case of picking a model off of printables and then firing it over to your printer, you have all the settings and customizability that you would ever need. Personally, unless I'm in the office, I almost always slice my files through EasyPrint now because it's faster, it's easier, and it prevents me from getting sucked into things on my computer like emails and messages. So that's a slicer that makes it much more convenient to slice your files, but what if you're really not sure what to actually do when you slice them? For that, there's JusPrin, an OrcaSlicer fork by the folks over at Obico. The idea behind JusPrin is a pretty simple one. You take a normal slicer and you add an AI that can see and modify your settings for you. Now, I spent a little bit of time just testing it out while researching this video, and it does indeed change the settings in a mostly logical way. But perhaps it's because I'm already a pretty advanced user, I found its suggestions to be just a little bit off. It added tons of infill and perimeters despite being explicitly told to maximize strength while minimizing weight. It added way excessive supports to any overhang despite the angle. And don't get me wrong, I am probably going to recommend JusPrint rather than Octoprint to folks like my 83-year-old dad whenever he gets tired of me slicing everything for him. But for now, I would really only recommend this for absolute beginners as a learning tool rather than a one-click slicer for everyone else that does everything for you. With that said, they are looking for beta testers, and the nature of these things tends to be that they get exponentially better very fast. So if this sounds interesting to you, or you're still learning, definitely hit the link in the description and get involved. Now, on the complete opposite side of the spectrum, we have another OrcaSlicer fork. God, there are so many of them these days. Can we all just agree to start calling them ForcaSlicers? This one, however, is a fork of the Snapmaker fork, otherwise known as FullSpectrum. Now, you've probably heard a bit about FullSpectrum already. It's been making the rounds on YouTube and elsewhere, but if you haven't, here's the pitch. Using dithering, you can blend colors in a way that tricks your eye into seeing colors and shades that aren't there. In fact, if you use CMYK filament, you can theoretically create all 16 million colors in one 3D print. But even without special filament, you can easily create different shades of more normal colors. Take, for example, this print that I did for my son, which uses 4 different filaments, but combines them in unique patterns to get 12 different colors. Super cool, and honestly, not nearly as slow to print as you might think if you're using a tool changer like the Snapmaker U1. By the way, if you'd like to learn more about FullSpectrum, my buddy Taylor over at YGK3D did a phenomenal job explaining it in his recent video, so I'll link to that down below, which you should check out after this video. Finally, I know some of you have been asking for this one, so I am going to include it here just to let you know that I did test it and play around with it. It's called preFlight, and it bills itself as the spiritual successor to Prusa Slicer, despite the fact that I'm pretty sure Prusa Slicer 3.0 is gonna fill that role. Look, I was always told that if you don't have anything nice to say, you shouldn't say anything at all, so I'm going to keep this one relatively short. I am very glad to see that there are folks out there who are still forking from Prusa Slicer and trying to do innovative stuff. And some of the features being advertised on preFlight's website, things like interlocking perimeters, nip and tuck seams, and multi-type supports in one print, are genuinely interesting. I don't doubt that for the very advanced or industrial user, this slicer does pack some seriously innovative stuff under the hood. Unfortunately, I found the process of migrating my profiles over from OrcaSlicer to be a lot more frustrating and a lot less comprehensive than promised. Plus, the interface seems to be a step backwards from Prusa Slicer, not forwards. What's more, I really couldn't help but wonder, why not submit these exciting new ideas as pull requests to the already wildly popular OrcaSlicer? One way or another, I found myself uninstalling preFlight within minutes, sorry guys, and running back to OrcaSlicer. But at least I tried. And hey, I know that plenty of you will go ahead and let me know in the comments why I'm completely wrong, how amazing preFlight is, and how I'm just not smart enough to get the appeal. For our last category, we're looking at the wild, wild west of 3D printer filament, with a series of websites to help you find, understand, and organize your filament. Have you ever wanted to find a specific filament with the exact shade to match something else? Or wanted to find all the manufacturers that make a specific, rare type of filament? Well, then 3D Filament Profiles is the place for you. Not only are they tracking over 26,000 different filaments across 48 material types from almost 1,000 different brands, but they even aggregate the exact colors, detailed recommended print parameters, data sheets, transmission distances for HueForge, and a whole lot more. You can even download printable QR code labels, you can check inventory on various websites, or double check the drying recommendations. Really guys, this site is absolutely insane, and in one fell swoop, it seems to have absorbed the functionality of like half a dozen previous community efforts like Filament Colors XYZ, Filameter, My Filament List, Spoolman, and a whole lot more. And that's honestly just the tip of the iceberg. You can track your own filament collection, including how much of each spool is used and where exactly it's being stored. You can upload 3MF files to automatically subtract filament from your spool inventory, and they're currently in the process of adding a comprehensive library of 3D printers, AMS systems, build plates, filament dryers. It's a lot. And somehow, this site is being run for free, and the author isn't even using affiliate links for most of the products, which honestly is insane to me. So do go check it out, sign up for an account, and please consider dropping them a few bucks if you find this thing valuable and want to see it continue developing. But the one thing that 3D Filament Profiles doesn't seem to do is actually educate you on the 60+ different filament types out there, or when you might want to use one type over the other. And given that I've now done like 7 or 8 different videos over the last 3 years trying to do just that, I figured who better than me to create a resource that does. So recently, I launched the FiLibrary over at filament.thenextlayer.com. It's just a really rough prototype right now, but the idea is this. For each filament, I want you to be able to understand at a glance what it's like, what it's good for, and its various strengths and weaknesses. Now, what's cool about this is that these explanations and graphs are not just generative AI nonsense. They're actually taken from the tens of thousands of words that I've written throughout the history of this channel, plus actual data pulled from real datasheets. Most importantly, there are links to the exact video where I introduced that filament, so you can see some sample prints and use cases. Now, I have a bunch of other ideas for major improvements and upgrades, including the ability to compare filaments or an AI-powered advisor that actually helps you pick the right one for your next project. But before I put in a whole lot more time and effort in it, I thought that I'd put it out there for all of you and see if it's any use to you. So I'll go ahead and leave a link to that down in the description below. Or if you just want to dive into the deep end and start learning right now, you should definitely check out this recent video we did. In it, we tested out 17 of the most unique special purpose filaments that consumers can actually get their hands on to try to understand what type of projects they enable us hobbyists to do. It was a lot of fun to produce with some very interesting and eye-opening takeaways. I think you guys are going to absolutely love it. That's all for this week, but I'll see all of you on the next layer.